Hello and welcome to our webinar. I'm Matt Griffin, Director of Community Development for Ultimaker. For this webinar, we are going to focus on a key area distinct to additive manufacturing solutions that build up objects layer by layer, especially in 3D printing technologies such as FFF, as used by Ultimaker. The use of support materials to prop up overhanging features higher in a build. By adding a support strategy, you eliminate the frustrations of trying to drip molten plastic into midair and experience the geometry freedom additive manufacturing can offer to produce any shape or design needed, and without needing to engineer how to cut, mill, burn, turn, punch, or bend those features with other fabrication technologies. Support material options open up the full potential of 3D printing technology to make a difference for your business. A brief overview of the details we will cover today. First, we're going to share how Ultimaker operators address support requirements now, discussing support structures using the primary build material, PVA water-soluble material, and then breakaway support material as well. Next, for the first time ever, we will highlight a new support material option developed by Infinite, a member of the Ultimaker Material Alliance, AquaSys 120. We will explore AquaSys 120 with Ultimaker engineering materials and then invite in the Infinite team to share examples they have for using AquaSys 120 with other advanced engineering materials from the Ultimaker marketplace. We'll wrap up with some advanced tips and tricks, a live Q&A, and send you on your way. A little bit of housekeeping. The runtime of our webinar will be roughly 40 minutes, but we might go over. There will be a Q&A at the end, and you're welcome to ask any questions you have via the chat box in your browser all along the way. We have team members standing by, eager to help you with your questions, and stage a few of them for our discussions at the end. If you'd like to watch this webinar again, we're going to send you a link via email after this session to make sure you don't miss anything. Thank you again to all the attendees in real time or on video repeat who join us. Your valuable time means a lot to us. Okay, so while this area we're going to cover now may be well-trod territory for many of our viewers, it is worth sharing the basics of support material strategies for FFF to get all of us on the same page together. As I mentioned earlier, the need for a support strategy is a natural requirement when using an additive manufacturing technology such as FFF extrusion, 3D printing as used at Ultimaker. In this technology, you build your part layer by layer, starting with the lowest layers and fabricating the part in horizontal deposits of plastic stacked up from those bottom features to the top ones. Therefore, any unsupported features, such as arms of a statue held out away from the body like this, would simply drip plastic all the way down onto the plate if there isn't anything underneath those drips to suspend them while they cool in place. If you neglect to support these features, it is called dropping loops because of the distinct loops that are cast down by gravity without a support strategy in place. And they can cause problems from small part inaccuracies all the way to causing the failure of the build as a whole. So the original solution available to anyone using a 3D printer is to produce the support material using the primary build material. Using 3D control software such as Ultimaker Cura, you can activate support material generation, indicating an angle, usually around 45 to 50 degrees, at which support material should be produced, and these additional paths are then added to the final model when it goes to the printer. The ways that the plastic is laid down as support material can be configured a number of ways, but most of the approaches are such that you waste a minimum amount of plastic on the support scaffolding and can easily remove it away from the intended features of the build after the part has cooled and been removed. Ultimaker Cura has a number of options allowing support features to be generated, everything from using per object settings to place your own custom designed support objects, to experimental techniques such as tree support patterns that are highly efficient for certain types of geometry. Starting with the Ultimaker 3 and continuing into the Ultimaker S line with the S5 and S3, operators have the opportunity to build their parts with two materials at the same time. This opens up the opportunity to print using dedicated sacrificial support materials that are ideally suited to providing support scaffolding. These materials are engineered to be easily removed from the primary build part without all of the chipping, cleaning, sanding, and healing that was more typical when you had to print support scaffolds using the primary build material. Those additional strategies I mentioned that are possible in Ultimaker Cura for single build support techniques gain further value in a dual extrusion machine. Now you're able to not only pick a solution that perfectly matches the supports in terms of the type of geometry used for your intended part, but you can also match the material selected for your primary build with exactly the right support material designed to reach your intended final part faster. Are you an architect or designing a simple housing where most of the unsupported features are on the outer perimeter of your object? You can use breakaway materials that do not chemically bond with the primary build material and can simply be pulled away from the surface using pliers when you're done. Have lots of crazy cavities, such as an anatomical model of a human heart or a print-in-place mechanical motion element from a functional machine prototype. Elements that would be impossible to remove by hand using simple single material strategies. Well, PVA water-soluble material can really save the day. Considering the topics of this webinar, let's summarize why one might use dedicated support materials. The benefits are design freedom for complex geometries, overhang angles that can be less than 45 degrees, producing internal cavities and single part hinges where removing the primary build support would have been impossible. Very important to engineers testing and qualifying parts, these strategies allow you the freedom to select a part orientation to focus on addressing anisotropy and stiffness properties for your final part and ignore many of the fabrication requirements for producing the part. Things that can be blockers for using dedicated support materials. These specialty materials can be expensive and result in long print times. Stay with us at the end of the session and Ganeil will share some of his favorite tips and tricks for being highly efficient with your support material use. PVA is easy to use, easy to remove with many of our lower temp materials, but no good with high temp engineering materials or materials that don't bond with it. Breakaway material is really great for fast removal when your support features are on the outside, but can be extremely difficult to extract from internal cavities and highly complex organic surfaces. Let's take just a moment to highlight the value of Ultimaker Cura for support. Using the easy print and intent-based profiles, activating support is as easy as flipping a toggle. But under the hood in custom mode, there is even more power. You can produce a custom support geometry. And we have a recent webinar on the topic that is well worth reviewing. There are a number of patterns that are not only great for finding the right way to support tricky parts geometries, these are also solutions such as gyroid infill that offer more surface exposure during dissolving processes, allowing you to sluice PVA support material away faster than using other patterns. There is a wealth of resource within our Cura manuals, tooltips, and setting reference plugins within Cura and Ultimaker.com's website and online community. Enough for an entire semester-long course in intermediate and advanced techniques. But now that the basics are out of the way, it's time to bring in Ganeil, our materials expert, to share insights and example projects that help illuminate the process of using the two Ultimaker branded dedicated support materials in our catalog. Ganeil has an advanced educational background in materials science and engineering, an area that attracted him because of his passion initially for high-tech composites that he encountered while sailing. His interest in marine crafts transmuted over time into graduate studies in spacecrafts, with work in 3D printing in low and zero gravity, contributing to projects for the ISS and future lunar exploration. Ganeil left work on satellites and smart glass and glazing materials development to focus 100% on additive manufacturing here at Ultimaker, first in R&D and now working directly with our customers, while continuing to work with the team to expand the material possibilities for Ultimaker solutions. So welcome to the show. It is such a pleasure to have you, Ganeil.
Hey, thanks, Matt. I think that was a great introduction on the support material in general. So I'm going to deep dive a bit into PVA. Well, PVA is, I think, one of the most known material in the, support material in the industry. It's water soluble. It's compatible with PLA, tough PLA, CP, and nylon. And worth mentioning also sometimes that you need to keep it out of like a moist environment, so because it's really water sensitive, so you really need to keep it in mind. So today I took this example, which is an inline skate functional prototype, and the advantage of this of PVA basically is that you can really print like small features using the support material. So thanks to PVA, like I could really print this functional prototype directly like this. So I knew that we could use. I mean, it could be functional itself. So that's really important. And next to that, like it's not only about like small features, but you said it before. It could also be like internal cavities where we need to dissolve the materials afterwards. Yeah, I think in my opinion it's a great material. Like the surface finish that you can achieve using this PVA is really great. Like you don't really see a difference between without support and with support. So yeah, in my opinion, one of the best support materials, of course. So next to that, we also have a complementary material to a portfolio, which is called breakaway. And as its name stands for, like you just need to break it away afterwards. So it's a very time-efficient material, so easy to print, and also what we do a lot with our customers is that it enables us to add text directly on the application, and it's very useful on the production directly, like at our clients. Here, I do have this application, which is a label gauge, so for quality assurance purposes. And in this application, so it's just to check if the sticker is really aligned well, and this is where the quality assurance test stands for. So, yeah, that's the easiness of printing with breakaway, and also the compatibility that is interesting because it's also compatible with more higher temperature materials such as ABS or CP+, but also the same as for PVA, so nylon, CP, PLA, and tough PLA.
Well, thanks, Ganil. While PVA and breakaway have already made a real difference for Ultimaker customers for their support strategies, they are not without their limits. Take, for instance, this material compatibility matrix. There are bonding limitations for working with some of our higher temp materials and some of our other engineering materials. Take polycarbonate, TPU, polypropylene. Each of these suffer from incompatibility. The approach taken for these materials is typically to produce the intended part using support structures printed in the primary build material, and then clipping, cutting, breaking away those sacrificial parts. This can be a frustrating process for super stiff and sharp materials such as polycarbonate, and it is very hard to clean up and heal support contacts on TPU and polypropylene. And that's what brings us to the most exciting highlight of this webinar. The Infinite team set out to target a dedicated support material filament that required nothing more than tap water, agitation, and heat to dissolve, without requiring any chemicals or dissolving agents. The multidisciplinary team drew on a combination of concepts from chemistry, physics, material science, adhesive science, polymer processing, biotechnology, and food science to release an option that goes further than the previously available support options. AquaSys matches many more materials than the other available support products and within a wider range of processing temperatures. Some of the key properties to consider for AquaSys are more versatility in terms of material compatibility, works with advanced engineering materials such as Ultimaker polycarbonate or polypropylene. And before, I will say that polypropylene could only be printed with polypropylene as the support. Nothing else would stick with it. AquaSys 120 will dissolve in water. It has an excellent surface quality, and better bonding means successful support for complex internal features as well. So Ganel has been using AquaSys with a few options in the Ultimaker catalog that are not compatible with existing support materials. Ganel, do you want to tell us about your success with polycarbonate?
Definitely, Matt. I mean, this is great for us. Like, we can finally print all the materials with support and more like high temperature materials directly. So I bring today this example from a customer, which is a packaging holder. And from this example, I mean, I really needed to print it with polycarbonate because of the stiffness, of the temperature resistance, and also next to that, these parts needed to break in case of a jam. So we need stiffness and low elongation at break. So that's why I choose polycarbonate, and I really wanted to print it on the side to give actually the mechanical resistance to the parts. So there I needed this a support material that will enable a great surface finish that will not damage the packaging itself. And yeah, AquaSys 120 was the right choice for this application. So yeah, great to have it. And I have another example with like this is a polypropylene. It's a pipe junction, and as you can see, like the structure itself really needs support. So this application needed to be in polypropylene for the chemical resistance and the semi-flexibility of the part. And as you might know, polypropylene doesn't stick to anything, just to itself, as Matt said before. So we needed to find the right support material, and the right support material is AquaSys 120 in this case, because as you can see, like the structure is like, I mean, it's bonding really great together, and when you dissolve it, you really get something neat. So the surface finish is perfect.
Thank you so much, Ganel. Having worked with those materials in the past and printed them with the primary build material and cleaned them up, I really want to try the solutions that you're doing. So thank you. So Ultimaker hardware has an open filament system. That means that there are a huge range of materials from third-party material companies that can be considered.
Yeah, Matt, I mean, it's incredible. Like, you can really think about all the high temperature materials, such as PAH with a carbon fiber, for example. And this is where AquaSys 120 like gives value to these materials, because you can now print supports.
Well, we're excited to be working closely with Infinite. And because of the high temperature rating, AquaSys 120 versatility goes even further. We can use it for these other materials in the marketplace that Ganel was talking about, and other materials that we don't have other bonding solutions. Today we are joined by the lead R&D supervisor at Infinite Material Solutions, Brandon Cernohouse. He's been heavily involved in the process and materials development for AquaSys, and draws on 15 years of past experience in plastics and additives. But first, Brandon, can you tell us what material properties your team pushes for when developing a support material like this?
Hi, Matt. Designing support materials is very tricky. You have to really consider a lot of different factors when trying to figure them out. First of all, you have to have excellent adhesion to your model and also to itself. And then with us, we've targeted to be broadly compatible with lots of different materials, and that's so much trickier to do than just doing a single pairing. Other super important features are you have to have enough modulus and stiffness at the temperatures you're going to be working in to prevent deforming and melting when printed on. It's really hard to get a very robust material. You also have to have excellent dimensional stability, so that way you aren't curling or warping and losing your part precision. Then you need self-adhesion for good bonding and Z-strength for, if you're going to make the part out of something, if you want to make a part that's for a sacrificial core or something else, the part itself needs to model well. And the last and one of the most important things we've been still trying to follow too is that it's truly a water-soluble polymer. Not a, soluble in chemicals or sort of soluble, but truly water-soluble in reasonable conditions that the general user is going to be able to actually use. So.
That is really helpful. Brandon, thank you so much for coming and joining our webinar and bringing, all those years of expertise around this kind of development. So Brandon has brought with him a number of top requested high performance materials from the Ultimaker Material Alliance and Marketplace, and we'll be showing you how AquaSys introduces the option to use dedicated support material to some of these. So take it away, Brandon. Share these amazing examples.
All right. Thank you, Matt. So today I have 3 materials with me that I'd like to showcase. We have the Huntsman Aeroprint TPU, we have the Solvay Solef PVDF, and we have the Lehman & Voss polyamide carbon fiber. These were selected for their unique compatibility with AquaSys. These materials really didn't have great support options on the market, and AquaSys, we feel, really enables more complex geometries and really easy soluble use case. So first up, we have the Huntsman Aeroprint TPU. This is a soft touch polyurethane. Polyurethanes are really kind of the only soft touch material on the FDM market right now, and they're great for doing lots of different cool things. They're great for wearables. If you need anything that's touchy-feely, if you need functional parts that are compressible or tear resistant, like a gasket, really anything you need that's flexible, squishy, tough, tear resistant, TPU is a really good bet. So this particular part was selected because when printed without support, the seams were kind of failing in these overhangs. But with support, this part turned out really good looking. This particular part is kind of like a handlebar, something that would go on a bike, but kind of different. This was printed with pretty close to the default specs, but just a little bit higher temperatures. So next up, we have the Solvay Solef PVDF. PVDF is a really interesting material. It is chemical resistant, abrasion resistant. It has a relatively low coefficient of friction compared to most of the other FDM materials out there. It has good UV and kind of inherent flame properties. So it really kind of positions it uniquely in the market. It's really commonly used in the wire and cable industry, as well as in the chemical industry, specifically for gasoline resistant is one of its more unique properties. Through bizarre coincidence, we managed to pick the same part as the Ultimaker team. I don't know what the odds of that are, but it's staggering. But either way, it's a really cool part that really needs anything with long tunnels and little pinholes. Getting those supported and cleaning them out, it can be a real challenge if you're using breakaways or solubles that aren't totally soluble. 100% water-soluble materials really make this part turn out well and easy. The PVDF pairing, it's a tricky one to get right. We had to go really hot on almost all the printer settings to manage curl and warp and to get everything to stick properly. But we ended up with a pretty nice looking part. It also took a draft shield and some of the other good tips and tricks to really get the support right and to turn out. So then last, here we have the Lehman & Voss polyamide carbon fiber. Polyamide carbon fiber, it's a really tough material. It's stiff, it's relatively impact resistant. It's a really strong, good material. generally speaking, the filled materials are harder to adhere to than the non-filled versions. But the AquaSys 120 has great adhesion to the polyamide carbon fibers, which is great. So other places you might see a material like this, you might use it for jigs and fixtures. You might use it for functional parts. If you need something strong, if you need a hanger or a complex fixture to hold your part, it's great. People also use it in the automotive industry for somewhat close engine applications due to its strength and decent heat resistance. This particular part was printed with support just to make the long overhangs print really cleanly. It looks really great. It's a really nice part. And best of all, this part was printed with just straight out of the box default settings with both profiles. Super easy pairing, really great. It really doesn't get much easier to print than this.
Thank you very much, Brandon. We really appreciate you joining us today to share your expertise in both additive manufacturing and in specific with AquaSys.
Thanks, Matt. So we have a couple of great new innovative products that we'd love to show up in the future. We'd like to talk just a little bit about our upcoming AquaSys 180 product, which is meant for super high temperature chambers, and that will pair with the really high temperature polymers, PEI, PEEK, PEC, and all the great stuff. And then after that, we're looking at our first model material, which is also going to be super cool. So thank you.
That's fantastic. Well, thank you again for coming. And now we're going to actually bring Ganeil back, who will share some of his latest tips and tricks for all of the dedicated support material usage he has been experiencing out in the field working with our customers. Ganeil?
Yes, so my tips and tricks around support materials. So first of all, I would like to tell people try not to use too much support materials if possible. So we really try to minimize it in general in applications. But for a lot of applications, and mostly complex applications, we need to use support materials, so whether PVA, breakaway, or AquaSys 120. So there are different ways to minimize your support material. The first way will be to use only the interface layer as a PVA, for example. So in this case, you're gonna print your support with the build material, and then just for the interface, print with PVA. So meaning that it's gonna be cost efficient and also in terms of printing time. And this is a great way to minimize your support material. The second way will be to decrease, for example, the support horizontal expansion settings in Cura. And by doing that, you can just reduce the amount of support and so the printing time. The third one that I would like to tell you is to use custom supports, meaning that you can import your model, another model, into your print job, let's say, your Cura project, and this model, you're gonna print it as support, and you're gonna use for that the mesh per model, and printing as support directly. And for example, you could think about really conical supports, so then you just have the surface on the top, and the conical parts will just be dissolved afterwards. And so you don't have to print a full rectangle with support materials. And after that, I would like to give a bit more tips and tricks around support materials that might be valuable for breakaway more. And for example, if your adhesion with breakaway is a bit too much, there is too much adhesion, and you still see after removal some white stripes on your surface, then in this case, it will be good to play a bit with the gap distance between the support and your model. This is a setting that you can play with in Cura, and this is not the only one. For example, you could also think about decreasing a tiny bit the temperature of breakaway just for the surface. And after that, you could also try to align the lining up, meaning that when you print the top surface, you can think about doing like only 180 lines and not to have like lines in 45 degrees directions. And in this case, if it's aligned together with the part itself, and then it might be easier to remove the support afterwards. So these are my tips and tricks.
Thank you so much, Ganil, for bringing those tips and tricks. There were some really excellent ones, and I really hope that the viewers pick up a few and add them to their tool belts to use for their next projects. Thank you for joining us.
Hey, thanks, Matt. It was really great to be there and to share my general knowledge around support materials and applications. And I really hope that my insights were helpful for viewers.
Well, I can just about guarantee that you will see some exciting support activity happening out in the world thanks to your tips and tricks and your really useful examples earlier for how to use polycarbonate and polypropylene with AquaSys. It is worth mentioning that since the Ultimaker 3 launch in 2016, our team has dedicated itself to providing an excellent dual extrusion and dedicated support experience for our hardware. The unique approach to the second tool head on our machines, for example, was to engineer such that the tool head either lifts out of place or drops down into place at a distance that prevents ooze scarring on the part from being produced by the idling tool head, a problem that in the past was very common for dual extrusion machines. As the AquaSys 120 profiles are available in Ultimaker Cura for download from the Ultimaker Materials Marketplace, it is possible for our customers with Ultimaker 3, S3, and S5 to download and use these immediately. What's more, customers with the Ultimaker S5 Pro Bundle with the Materials Station can use AquaSys in a scenario that actively keeps AquaSys stabilized in a low humidity environment, which can be a real help when working with a material that dissolves in water. The Pro Bundle has dedicated profiles validated for the use there to give you peace of mind when printing with Ultimaker PVA, Infinite AquaSys 120, and also Ultimaker breakaway material. All right then. I hope there have been some really useful takeaways and ideas for what is possible today with dedicated support material. While it doesn't always feel like the most important thing, the flexibility and power brought to 3D printing by using dedicated support material really unlocks a lot of applications, a lot of material pairings, and helps you get your work done. So thank you very much for spending time with us, and we look forward to chatting with you shortly in the live Q&A.